Okay, in this video we're going to take a quick look at the InStep application. This will be a relatively short video. It's going to be an overview over the general process and the capabilities of the application. When you first start it up, you'll probably get the login screen, the trial notification. We're going to click through that. I'm going to log in here. And I recommend that you set the remember me on this computer, that way you don't have to log in every time. So the application interface is just a little bit different from the previous version. This focus is on getting things more consistent, higher quality display in general. So you'll see this is optimized for a high definition display, so the icons will generally be smaller. What I'm going to show here is just a quick view over how we can import files, what the different tabs are, and then how you can export a file and what the results are. Each of these tabs will cover in more details in follow-up tutorials. This is really just meant as a quick introduction. So you can import a file through the file dialog, import file, or you can just go ahead and click open. Alternatively, you can also drag and drop a file in here. I'm going to go ahead and I'm going to load this file here. You can see it's actually very small. This triad in the background is showing a unit. In this case, this would be millimeters. So what we're going to go ahead, we can do the resize button here, or we can just click on the units down here. It brings up the dialog. And in this case, the question is, what are the work units that we want to use in general? And then what is the original data that it should be in? So if we're working in millimeters, which is just the easiest one for me, it's quite universal. If we say, okay, if it were imported in millimeters, then the scale is 1, right? But if the original data, if each value in there was actually meant to be a meter, then we need to scale the data up by a factor of 1,000. So we can preview it, that looks fine. I'm going to go ahead and apply that. Now usually the graphics will be stuck like this. There's a keyboard shortcut, there's Control Home will completely redraw the display data. So now we can see that here. So it's a factor of 1,000 larger. And if we zoom in, we can actually see that this is showing us 1 unit. Okay. If we want to take a look at the underlying detail, we can also turn on Edge Display Mode. That the shortcut for that is Alt-E, which can also be found up here in the view. So right now we got edges, we can toggle these on and off. We can also toggle the vertices on and off, faces, etc. Shortcuts for these are shown: Alt-F for faces, Alt-E for edges, and Alt-V to show the vertices. Edges is a very good way of getting an idea of what's actually in there. So back on the import tab, we've got different options here. We can do a quick info on the data. We can see that these are the ranges of data points. We'll cover all of this in more detail in a later tutorial. If we wanted to go and edit data, so underlying triangles specifically, so edit here deals essentially with just the triangular data. We can go in, we can delete individual triangles, we can select them, click delete. The trick here is that deleting, flipping, creating is only temporary. You have to click the apply for it to become permanent. So we want to go ahead and cancel that. This isn't quite an undo option, but it's an undo for detailed items like that. The application itself does not have an undo option at this point. Some of these repair tools operate more on the entirety of it. So for example, fix all holes. That looks for any kind of patches where edges don't form a closed surface. If we wanted to do that individually, we've got fix hole singular here, and we can select individual holes, and we've got extra options there. If we go over to the bodies tab, we can see tools that are more aligned to work with the entirety of this data. What I mean with that is, for example, if you wanted to simplify this, if we just look at this and we see over here it's got 17,996 features, or triangles in this case, we can say, well, that's too many, we want to have fewer. We can say an absolute, and we can say, let's go with 5,000. We can click preview, and now we see the data displayed in a previous state. The light blue is always a previous state. So we can easily go ahead and undo that with the red X here, or we can go ahead and apply that data. And then we close this tool out. So now we're actually left with 5,000 facets. If we hover over the All Trace option here, it says there's only triangles. That's what Trace stands for in this application. And that we have one body, B1, and 5,000 facets. This will generally update as we do these operations. The reverse engineering tab has a lot of new features in it, and they basically fall down into feature-based and organic. So the feature-based has to do with very geometric data, boxes, squares, things like that. You cannot really use that for an organic body like this. The organic shape options here allow us to do reverse engineering in terms of the overall surface more than the underlying geometric features. So we have really just two options. We can have auto surfacing, we have manual surfacing. The manual surface or patching tool is intended if you only need a small segment of the data to work with. So for example, if you wanted to create a metal plate that attaches to the surface and you only need the curvature of this surface here, we'd use the manual patching tool, pick a few points and turn that into a surface that we can then export. And again, these are tools and details we'll cover in later tutorials. The auto surfacing, for example, what you can do is you can go in and you can say, okay, I want to divide all of this data up into a few hundred patches. Let's say something like that. And then there's different algorithms to use. We're going to use a sampling algorithm. First we'll turn the edge display off to show what it actually gives us, and then we'll generate a preview. So what this will do, it'll go in and it'll try and generate surface patches to go over that and create the original. Now what we can actually see, this is a new feature, we got the approximation of the surface. So it takes the output from this and then says, okay, if we're only going to use that, what would the underlying surface actually look like? And we can see here it would actually fail. So we're going to go ahead and turn that off. We don't want to do that right now. We're going to redraw this. We have some leftover artifacts. So we're going to do Alt Home again and force a redraw. If we just want to do the facet data as it is, so we want to just stick with these triangles that we imported and reduced, we don't need to apply anything else. We can just go in here, do import file, pick the same data again, we're going to size it again, and then we can just go ahead and export it. This is all that's needed in order to convert an STL or an OBJ in this case to a step file. Import, then export. And in this case, if I open SolidWorks and I import that file, it'll read it in and it'll take a look at the underlying data. And in this case, it's just a set of triangles that have been converted to surfaces and tied together into a solid body. So there's no specific conversion or anything like that. It's just an import and an export. We can run a surface diagnostic on this, and we'll see that in general SolidWorks will say yeah, it's fine as is, and then we can go ahead and do what we want with that data. And this is a solid body, so we can drill holes through it. We can use other items on there as references. Last tab is the View tab. We briefly touched on that. Show faces, show edges, show vertices. There's also some other items here. We got different standard views that we can switch to. Or something I always find interesting is if we rotate it to view in a certain direction, then just want to snap it. We can pick the closest view and it'll just snap to whatever that is. We also have our default orthographic and perspective views. Depending on what you're working with, these may come in handy. Triads and origin. We have the triad down here and then the origin that we briefly touched on. We can turn these on and off depending what we want to see. We can also set a pivot point, which is important when you're working with data that you want to rotate around. You can either specifically set it manually. We can then show it. Right now it's in the center. You can see it right here. We can set the coordinates of that, or we can simply pick with the middle mouse button on a certain location and then it snaps to that point. We can export an image. We can also change our backgrounds in case we want to have something a little bit more fancy. And we can also turn on brightening. What the brightening does is if you happen to be inside a body, so we'll set the rotation point here, and then we'll rotate so we're looking at it from the inside. We can turn on this just to get a slightly better view inside of that. Lastly, the locations. This is a comma delimited set of points that you can provide, and it will then create a geometry as a way of displaying that data. So if I were to just take that, add a slight Z offset, now you see there's a line between those points. If there's 2 points, it's a line, 3 points, it's a triangle, and so on. And that's the introduction to the InStep Studio 3D version 3.1. This will be part of a longer series of tutorials that will cover the use and application. I recommend you check back frequently as these things will change. New features will come in, bugs will be fixed, and so on. But for now, this should give you a basic idea of what the application can do and how to navigate it.